All right, welcome to day 2 of trigonometry. We are now going to talk about the inverse. When we're talking about the inverse, we're talking about looking for a missing angle. All right? So the first thing we're going to do is we're going to be writing the equations, and if we're missing an angle, we're going to use the inverse trigonometry. Inverse is just opposite. Inverse operation, solve for x. You use the inverse operation, opposite operation. Again, the only thing we need to focus on is these little symbols here. You'll see these in the calculator in a minute. This is my favorite one. It's so easy as long as you know whether you have SO, CA, TOA, whether it's sine, cosine, or tangent, and you set the equation up correctly. Literally, it's just bam. You don't have to remember switch and divide or multiply. Okay? So let's talk about first setting it up. You're going to notice these theta symbols. If you do not, and this one has an X, if you don't like the theta symbol, use X. Okay, it doesn't matter. Use P if that's your favorite letter. Okay, it does not matter what symbol, if you use a theta or a variable. They're going to represent a missing angle. So let's take a look, and we'll go through this pretty quickly. The setup, okay, just the initial, which one do we have, sine, cosine, or tangent. Reference angle is going to be that missing angle. I'm going to look, and I see that I do have my hypotenuse. I told you in the last video I'm going to start using H's and O's if you watched my video. Here, I've got my hypotenuse, so I'm going to shorten it up and just say I've got H. And then I do not have O. I do not have my opposite side, but I have my adjacent side, so A. So my A and H is with cosine. So the first thing we're going to do here, we've got ca, right? And I'm going to show you guys, instead of just jumping straight to what they have up here, what this ends up being, it ends up being the cosine of theta, or x, or p, or whatever you use for that variable, that missing angle, is equal to, you're going to have adjacent 2 over hypotenuse 5. So you're not missing anything in the fraction. So what ends up happening here is that to move that cosine to the other side, we have to do the inverse. We're just going to have that -1. You'll see how easy this is. So all we're doing is we're going to leave theta by itself. And when we move that cosine to the other side, we have to put this little -1 exponent. And then in parentheses, it shows you right here, we're going to write that fraction 2 over 5. Okay, and there's your equation. You're done. Bam. And honestly, if you set it up like this, this is correct as well. But we do want to see this, if I ask you for the equation. That way you can see, we know that you're using that -1 in the calculator, which I'll show you in a little bit. Next, reference angle. Got my reference angle right here. I am not using my hypotenuse. Okay, I do not label all 3 sides. I only label the 2 I have. Okay, if I'm not using my hypotenuse, over here I have my opposite, and I have right next to the adjacent that's not my hypotenuse. O and A are with TOA, tangent. So we'll set up that equation like we did. We'll have tangent, but instead of a number, we'll have the theta, or x, whatever you want, there, is equal to the fraction of opposite, 8, over adjacent, 8. And of all honesty, you can simplify this to just the number 1 if you want to. These fractions you can simplify, talk about with proportions. You do not have to. Okay, it's not going to make it any easier. You're just typing it into the calculator. The calculator literally does everything for you with the actual calculations. So we want to move that tangent to the other side. Leave theta by itself over here. But again, to move that tangent, we have to put that -1 exponent, or we're going to have it incorrect. And we're just going to have the inverse tangent of 8 over 8. And there's your equation. Done. I think that's a little bit easier, than you'll see, especially when we're putting in the calculator here. Next, number 3, here's my reference angle. Do I have my H? I do. Cool. What's the other side? Well, it's on the opposite side of the triangle. So we have H and O. We see that's going to be with our sine. So we're going to have SO and SOHCAHTOA. So here we have the sine of, actually, you know what? I'm just going to go ahead and do exactly what they have here. Okay, and they used x, so I'm going to do sine. So that way you can see what it looks like with x. It's the same thing. Is equal to opposite, 6, over hypotenuse, 11. So just like with the cosine and tangent we just did, let's move that sine to the other side. So x is by itself. We move that sine. What's important? Everybody shout it now. You got it, that -1 exponent. And in parentheses, just copy that fraction down, 6 over 11. And there is our equation. Now solving, my favorite. Now, jump straight into it, ladies and gentlemen. All right, number 4, where's our reference angle? Right here. Do I have my h? I do. And then the other side I have is not opposite. It's right next to adjacent. So we have a and h. And if we have our so, I know you guys can see it at the top of your page, but I don't have it on the camera. Toa. All right. A and H is with cosine. So let's go ahead and set that equation up. We've got So we have the cosine of theta or x is equal to adjacent 12 over hypotenuse of 17. Let's do what we did earlier. We're going to move that cosine to the other side. Theta is now by itself, and I've got to add that cosine with the -1, parentheses 12 over 17. What is so amazing about this, okay, and I don't know if it told us what to round to. Usually with degrees, I just round to the nearest degree, so we'll just do that. What ends up happening here with the inverse, okay, I'm going to clear my calculator from the last video. I'm going to first, before I do anything with trigonometry, am I in degree modes? Or am I in the degree mode? This is our calculators at home. Okay, I know that I plan on showing students which calculator to download and use, this calculator's at school. What to use at home, I would suggest using the Desmos calculator, and I'm going to show my students that in class. Okay, here we're looking for, we need to type in the inverse cosine of 12 over 17. Well, let's go back to that trig button. Look at the bottom. We have the inverses. Again, we're only going to be using the 6 on the left. Okay, so we have the inverse cosine. Look how easy this is, guys. I love this. No switching, dividing, no multiplying. Just go to the inverse cosine down here. Press enter. Oh, that wasn't enter. I don't know what that was. And then put in the fraction. Control divide. Okay, don't have to hold the control down. Control divide gives me that fraction. 12. Scroll down. 17. Press enter. Answer. Done. I absolutely love this one. Okay. So here we'll just round to the nearest whole number. 45.0 tells us approximately 45 degrees. And there's your angle measurement. I love the inverse. Next, here's my reference angle. Do I have my h for hypotenuse? I sure do. And then the other side I have is on the opposite side, so O. So this is going to be sine, SOHCAHTOA. So we'll have the sine of theta or x is equal to opposite 15 over hypotenuse 41. Again, let's move sine to the other side, remembering that to move him over, we have to have that exponent, and then it'll be the inverse sine of 15 over 41. And then in the school calculator, and this is all the work you have to show, in the school calculator, we go back to that trig button, and we have the inverse sign. Do not push sine. You have to go down to the inverse. Press Control Divide. We're going to put 15 on top and 41 on bottom. Press Enter. And theta or x, our missing angle, is going to be approximately 21 degrees. Round to the nearest degree on this one. Okay? I know if you're at home watching the video, you're like, oh, hopefully I remember what to do in the calculator. Just check with your teacher. We'll get you hooked up and make sure you understand the calculator. Number 6, reference angle. Just do the same thing over and over again. Okay? Reference angle. Do I have my h? I sure do. And then my other side is not opposite, but it is adjacent right next to it. Adjacent. So A and H, I know you can't see it on my screen, but you should be able to see it on yours, goes with cosine. The k in SOHCAHTOA. Cosine is adjacent over hypotenuse. So I'll just come down here and write this. So we have the cosine of theta or x is equal to adjacent 14 over hypotenuse 19. Again, there's no switching and dividing, there's no multiplying, none of that. All we're doing is we're going to move that cosine to the other side, making it the inverse cosine of that fraction that we just wrote, the 14 over 19. Okay? And then we'll go ahead and go into our calculator, and we will go to our trig function, and we're going to go to the inverse cosine, right? Inverse one. Press enter. Control divide to get our fraction function. We're going to have 14 over the 19. We press our enter, and we find out that we are going to have approximately 43 degrees. Okay, that 5 bumps that 2 up. So approximately 43 degrees. Last one. I really encourage you to do it on your own, okay? We are using different trigonometric function other than sine and cosine, but just find the inverse of it. Here we take a look and we have our reference angle. Do we have our h? No, there's only one that does not use h, and that's TOA, tangent. So we do have our opposite over here. That was a crummy little O. And then we have our adjacent. So this is going to give us our TOA, tangent. So if we have our, we'll set up our equation, the tangent of theta or x is equal to, we have our opposite, 23, over our adjacent, I'm going to say 18. Let's move that tangent to the other side. Let's get theta by itself, or x by itself. When we move that tangent to the other side, we need to include that -1, so it's the inverse. And then we just plug in that 23 over 18. We go into our calculator. Again, go to that trig function, and just, it's down here at the inverses, but now we're just using sine or tangent instead. No big deal. Okay. Get our fraction function. We're putting 23 on top, and we're putting 18 on the bottom. We round to the nearest whole number, theta or x, meaning your missing angle, will be roughly how many degrees? Look at that, 51.9, round to the nearest whole number, approximately 52 degrees. That is the amazingness of finding your missing angle. Just knowing your SOHCAHTOA and doing the inverse of the fraction you set up.